Hello everyone. In this video, let's learn how we can design the circuit for T flip-flop from JK flip-flop. We will also learn how we can obtain the truth table for it and the Boolean function for T flip-flop. So in previous video, we learned about how we can design the circuit for JK flip-flop from a SR circuit flip-flop. We saw that we can feed the Q state back in this NAND gate, make it 3 inputs, and we can also feed the Q bar back in the upper NAND gate and make it 3 inputs. So let's take a copy of this JK flip-flop circuit and modify it to make it T flip-flop. So here we took a copy of the JK flip-flop circuit. So in order to modify this to make it T flip-flop, we can do that very simply by feeding T input for both J and K inputs. So let's do that. We can introduce the T input and then tie it to both the J and K. So now this whole circuit here, it has mainly two inputs, T input, the clock input, and two outputs, Q and Q bar state. So the symbol for T flip-flop can be shown as follows. So we have T input, we have the clock, and then we have two outputs, Q and Q bar. So this is the symbol for T flip-flop. So the truth table for T flip-flop will look as follows. So let's derive the truth table. So we have T input, we have the current state Q, and we want to obtain the next state of the system Q plus. So for T, it's just like one input. So it could be 0, it could be 1. We only have two possibilities. So for 0, the current state of the system could be 0 and could be 1. Whenever we're deriving the truth table, we want to cover all the possibilities. So T is 0 in this case, we write it twice. And then also for 1, Q could be 0 and could be 1. So we write it twice as well. When a toggle is 0, the next state will be the same as the previous state. So here we'll have 0 and here we'll have 1. So this will be our hold state. And then when the toggle is 1, we're going to toggle the previous state. If it's 0, it becomes 1 only at rising edge or falling edge. And when Q is 1, the Q plus becomes 0. So this is the toggle. So we can simply rewrite the truth table as follows. So we have T, Q, and a Q plus. And then we have for T, it could be 0, it could be 1. When T is 0, we hold the previous state. So Q plus will be the same as a Q. And then when toggle is enabled is 1, so the next state will be the complement of Q bar. So me personally, I don't like to memorize things. I like to actually understand how we derive this table. So in order to do this, let's do it row by row and refer back to our full circuit up here. So the first row, we have the toggle is 0. So let's get rid of J and K to eliminate the confusion. So on the first row, again, the toggle is 0. So this will be 0 here. And also we'll have 0 here. The current state of the system, we're assuming it's 0. So Q is 0. So we want to figure out the next state after one step. So this 0 will come as an input to this NAND gate. And also if you follow this green line, it's a feedback input to the 3-input NAND gate. And we want to assume we have edge trigger. So the clock will have edge trigger. So this is 1 here and 1 up here. So the bottom NAND gate, we have 1, 0, and 0. For 3-input NAND gate, if you look at the table, you only get 0 when all 3 inputs are 1s. So for 1, 0, 0, the output will be 1. So R bar will be 1. Now from this NAND gate, we have 0 and 1. So also the output will be 1. So this Q bar will go in two places, but we're only interested in the upper left 3-input NAND gate. So this one will become an input to this NAND gate. So this top NAND gate, we have 2 1s and 0. So the output will be 1. Now looking in this section of the circuit, this is an SR latch. S bar is 1 and R bar is 1. So if we look back here, S bar is 1 and R bar is 1. So we have our hold state. So we verified the first row. So we have the hold state. For the next row, I'll let you practice this on your own. So you're going to assume toggle is 0, the current state is 1, and you're going to repeat the same thing on the circuit. You're going to end up with 1 and 1, so this will be the hold state. So let's do one of these bottom two rows. Let's do one of the toggles. So let's also prove that this is true. If the current state is 0 and the toggle is enabled, so the next state should be 1. So let's do this. Let's delete everything we wrote on the circuit. So in this case, toggle is 1. So this input will be 1, and then the bottom input will be 1. So let's assume we have edge trigger, so the clock is 1 here and 1 here. And then the current state is 0. So Q is 0. We want to see what will be the next state after one step. So this 0 will be an input here and also an input to this NAND gate. So the bottom NAND gate, we have two ones and 0. So the output is 1. So for this bottom NAND gate, we have 0 and 1. So the output will be 1. So this Q bar will be an input to this NAND gate. So when we have 3 ones for the NAND gate, 3 ones as input, so the output will be 0. So now for this row, we have S bar is 0 and R bar is 1. When S bar is 0 and R bar is 1, Q plus is 1. So that's correct as well. So we prove this row. So you can do the same for the last row and the second row to obtain the truth table for T flip-flop. This is all on the T flip-flop. I hope this was helpful. Thanks for watching. If you have any questions, feel free to comment below. Or if you need a specific topic, we can replicate this in Simulink to prove this circuit is correct. So just let me know below and I can create a dedicated video for this.